Hello, everyone, and welcome back to another episode of End of Mission, the podcast where we talk about space missions that have ended. I'm not the pressure-fed astronaut. And who are you?
I'm not either. That's somebody else. I'm wearing a mustache.
Over your mustache?
Yeah, a fake mustache over my real one. You always have to have a backup, right?
Yeah.
And I'm wearing the Groucho Marx goggles. Who am I? I'm Paul. I'm the monkey at the end of the Jimmy Neutron, with the three eyes. Remember? Hi, I'm Paul. Remember?
Oh, yeah, I remember that.
Yeah.
Just unlocked an archaic memory.
Yeah. Little brain blast there.
A little Jimmy Neutron brain blast.
Okay, so who are you?
I'm Face of Sarcasm. Who are you?
Good question. What are we doing today?
Oh my gosh.
This is your episode.
Yeah. So we are going to Mercury.
Ooh.
Yeah.
The car company?
Yes.
Ooh.
Yes. Okay, so next slide, please.
Slide. Yeah, okay.
So before we go to Mercury, we first have to discuss the Mariner program. Okay? So the Mariner program, it started up in 1960. Basically, this was the first actual effort to do interplanetary exploration. Right? So, it starts up in 1960, which, remember, NASA starts up in 1958. So NASA's only 2 years old at this point.
And already walking.
It's already walking. Yeah, already going to the other planets.
Aren't these based off the Ranger bus?
I'm pretty sure, yeah.
Because Mariners 2 looks like a Ranger.
Mm. Yeah, that's interesting.
Mm-hmm.
Thanks for pointing out the typo.
Yep.
Appreciate that.
Well, it'll be 2 and 3, right? Because they launched in
1 and 2.
Close enough.
Yeah. So, the whole point is that they are supposed to be small-scale, frequent missions to study the nearest planets, the inner planets, the ones kind of nearby. Remember, the solar system has the inner solar system, outer solar system.
They all tell the same jokes, right? Inside jokes.
Yep. The inner planets all have inside jokes with each other.
Yeah.
Yeah. And so basically they're going to be using the brand spanking new Atlas launch vehicle, right? It's not the Atlas missile. It's the launch vehicle now.
It's different because they put something different on top.
Yeah, and it's not supposed to go into someone else's house. It's supposed to go into space.
Yeah. I mean, ballistic missiles sometimes go into space.
Yeah, but then they go elsewhere.
That's true.
They go back down into someone's house.
Yeah.
Yeah. These aren't supposed to do that. These are going to space.
Well, I hope not.
Yeah. A few of them may have, but so the whole point is that they're going to be non-spinning spacecraft, right? So they have 3-axis stabilization. So these are not the spinning spacecraft that we've seen. It's not like with Galileo where like half of it's spinning, the other half's not. It is stable.
Yeah, it's stable. It's normal. 3-axis stabilization. A lot of gyroscopes then.
Yes, and we'll get to that.
Ooh.
So, first we had Mariner 1, which was destroyed during launch. Then we had Mariner 2, which did the first flyby of Venus. First successful one.
First working flyby. Because we know the Soviets did it once or twice.
Yeah. Ours worked.
Yeah.
Right. Then Mariner 3 failed during launch. Mariner 4 did the first successful flyby of Mars.
Yeah. Sent back pictures.
What?
Did it send back pictures?
I don't think it did. These early ones did not have cameras.
Cameras hadn't been invented yet, of course, right?
Right, yeah.
Back in the dark ages, yeah.
Yeah, this is back. Remember, this is the 60s, right?
Yeah,
Yeah. Cameras, right? There was this huge pixel shortage, right? They hadn't industrialized pixels yet.
Yeah, it was post-war, they were getting back up.
Yeah, exactly. Right. So then Mariner 5 goes back to Venus in 1967. Ooh. Mariner 6 and 7, they do flybys of Mars in 69. Mariner 8 fails during launch again. Yep. And then Mariner 9 is the first spacecraft to successfully orbit another planet, Mars, in 1971.
There it is. A little propulsion system.
Yeah. And also, because it's orbiting the planet, it could see all the stuff on it, like the giant state-sized supervolcanoes and mountains on the one side, as well as the enormous rift valley in Mars.
Yeah.
Yeah.
If I remember correctly, also, one of these Mariners Because the Soviets launched one of theirs at the same time,
Mm-hmm.
but the Mariners could be reprogrammed, whereas the Soviet space probes couldn't. And during the flight, we discovered, hey, Mars has giant dust storms when we're going to be there, so all the pictures we'll take will be, of dust, which
Yeah.
dust is important.
Gotta count it.
You got to count that dust. But we also want to take pictures of, Mars.
The not dust part.
Yeah, but the Soviets couldn't reprogram their spacecraft, so they took pictures of dust.
Losers.
And I think the Mariner bus was the basis for the Viking landers as well.
Yeah.
Like the orbiters.
Yeah. There was a lot of stuff with this. And also, because Mariner 9 discovered the enormous Rift Valley on Mars, they named it after it, Mariner Valley. Or, if you prefer Latin, Vallis Marineris.
Yeah. It's
Yeah.
a good name.
So, very successful. I mean, aside from when it's not.
Except for the times it exploded.
Yeah.
We forgive it for that. It
Yeah.
wasn't their fault, right?
So, next slide, please. Well, actually, hang on before we go. If you
Okay.
notice, it's going to the nearest planets, right?
Yep.
If you look down the list, you can see that we went to Venus, we went to Mars, and these all came from Earth.
Yeah.
But you notice one planet is missing.
Oh, we lost another one?
Yes.
Ceres.
No.
Oh.
The other one. Next
Yeah,
slide, please.
Okay.
Mercury.
Ooh.
Yeah. So Mercury, like all pretty much, well, most of the other planets, it was discovered in antiquity.
Yeah.
Right. Because you have Mercury, Venus, obviously Earth, Mars, Jupiter, and Saturn.
Yeah, because you could see them in the sky. I can go up in the sky and look at Jupiter tonight if I wanted to.
You can go up into the sky and look in Jupiter. Yes.
Yes. Get in my balloon and go.
Yep. Get your blimp.
Oh, wait. Well, the people in New Jersey might think it's a drone, so I don't know. I'm be careful. That's what's going on right now. This is coming out in February.
All right. We're recording this December 21st, 2024.
Yeah.
For catalog references.
Yeah.
Right. So Mercury is named after the swiftest Roman god. I don't remember which one, but the
Hermes.
swiftest.
Yeah.
Yeah.
Oh, it's a Swiftie. Taylor Swift.
Oh no. Oh no. No. No.
Oh, okay.
No, it's not.
Okay.
Okay, so the planet is that the radius? Yeah. So the planet has a radius of 1,500 miles, meaning it's about 3,000 miles wide. If you notice, it's not a very big planet, right?
No, it's kind of small.
Yeah, the moon has a radius of about 1,000 miles, so it's 1.5 times the width of the moon.
Yeah.
So it's not that big.
Isn't, I think, Titan or Ganymede bigger than it?
Both Titan and Ganymede are bigger than Mercury. It's about the same size as Callisto.
Yeah. Ooh. And
Yeah.
Jupiter's amazing. It's got planet-sized moons.
Yeah.
Or Mercury's a moon-sized planet. Who knows?
It's a moon-sized planet. So it has an orbital radius of 36 million miles, or 58 million kilometers, but it's the most eccentric, has the most eccentric orbit of all of the planets.
Yeah.
So it varies between 29 and 43 million miles.
And isn't it also inclined by like 7 degrees?
Yeah, it's weird.
Yeah, that's weird.
Yeah. So it has an orbital period of 88 days, or, it's because booking it around at like 30 miles a second.
Oh, yeah.
But it also has a rotational period of 59 days, giving it a solar day of 176 days. Right? So from noon to noon is 176 days, or 2 Mercurian years.
It's a long lunch break.
It's a very long lunch break, yeah.
I remember because everyone thought it was tide-locked.
Yeah.
Because it's close enough. And there was a short story written, I think it was by Larry Niven or somebody, that it was about someone trying to reach the coldest point in the solar system, the anti-solar point on Mercury.
Mm-hmm.
And it was published the day after it was proven that Mercury rotated.
Whoops.
Yeah.
Yeah. Also has an axial tilt of like 2 degrees. So
So it's just kind of sitting there.
Just kind of sitting there. Yeah. So it orbits really fast and rotates really slow. So that's great.
It's also proof. It's also proof of general relativity.
It is, and we'll get to that.
Oh, okay. You actually did include that. I don't know if you would or not.
Include some details. You'll see when we get there.
Okay.
Now, Mercury, as you can clearly see from these highly detailed images,
Ah, yes.
was very challenging to observe from Earth for a variety of reasons. Number one being, it was small. Number two being, it was far away from Earth. Number three being, it's really close to the big bright thing.
Ah, yes. Bit of a challenge to look at things, staring at the sun. It's like, oh, I'm blind. Can't observe Mercury now.
Yeah,
There goes my astronomy career.
Yep. Hard to do when you're a little bit blind.
Just a little bit.
Yeah. But as you can see, you couldn't really get a whole lot of detail about Mercury because of the reasons we just
Yeah,
discussed.
because you can't really look at it.
So this is essentially the closest thing. Oh, also I should mention before we get too far into it, I couldn't really find a whole lot of details for this in a variety of different sources. So I mostly pulled from The Voyage of Mariner 10, Mission to Venus and Mercury by James A. Dunn and Eric Burgess, because that's where most of the information comes from.
Okay.
Just for reference, and that's also where I pulled a lot of the imagery from as well.
I'm doing Messenger, and there's like 1,000 images I can look through. So.
Yeah, I don't have that same luxury.
Well, again, just, pixel shortages. We didn't have production rates.
Yeah, and plus, during around this time, the late '60s, early '70s, if you read the Spatial Decision, you know that in 1969, NASA put man on the moon. 1970, it was fighting for its budget.
Yeah.
Cut down to like a quarter of what it was.
Yeah. Big space programs cost money.
Yeah.
Who knew? Weird.
Going to space is expensive.
Who knew? What a weird concept.
Never would have thought. All right, next slide, please. So, Mercury is a challenge to get to. All right, the delta V requirements to reach Mercury are much higher than those for Venus or Mars.
I mean, somewhere
the Mariner missions are basically all doing flybys, except for Mariner 9. But even then, delta V requirements are low.
Yeah, we had to put a propulsion system on it, too.
Yeah. So a direct launch would require a more expensive Titan 3C, which they did not have the budget for. Again, NASA's budget is getting slashed.
Yeah, they're going to the moon. That's more expensive.
Yeah. But JPL was kind of interested in figuring out if they could do round-trip missions, like send a spacecraft or a space probe to a planet and then have it return to Earth. So they were using their big, fancy room-sized computers, plugging in the equations for a gravity assist, to see if they could do like round-trip missions.
Yeah, because you want to do sample returns, missions to Mars.
Yeah, stuff like that, right? And of course, the computer was coming back with a couple of different ones, like Earth, Venus, Earth, Earth, Mars, Earth, Earth, Mars, Venus, Earth. But then it came up with Earth, Venus, Mercury. So it's like, oh, wait a second. It was possible to use a gravity assist around Venus to get to Mercury in 1970 and 1973. They discovered this in like 1968 or 1969, so 1970 was a little too close to do mission prep.
Yeah, you couldn't build a spacecraft and have it working by then, even with all the tape recorders and all the stuff you needed for it.
Yeah. So they decided, all right, 1973, that's a good possibility.
Yeah.
Right. Now, I should probably explain how like a gravity assist works.
Do I need to go a slide?
No.
Okay.
So basically, I don't really have any visuals for this, but basically, okay, so there's two ways of accelerating a spacecraft.
Yep.
Thank you. The two ways of accelerating a spacecraft. Number one, with a big fancy rocket engine, but that costs money. The second way is with mass. All right? We have general relativity. Mass has the inherent property of curving space-time.
Yep.
Right. So basically, what you could do is, if you put yourself in a heliocentric orbit where you're orbiting the sun, that'll do a flyby of Venus.
Yep.
But when you get to Venus, you're doing a flyby of Venus, you get close enough to Venus where, because mass curves space-time, right? Basically, it's going to be using Venus as a roundabout, right? So it'll fling the spacecraft behind Venus, right, in the opposite direction of Venus. Now, relative to Venus doesn't really care, right? The spacecraft is just going to come in, swing around it, go back out, right?
It's a slight momentum exchange.
Yeah, it's a slight momentum exchange.
And momentum is mass times velocity. equals mass times velocity. You'll
Yes.
notice that Venus has really big mass.
It has a lot of mass. Yeah, it's
You
like,
won't
what,
notice.
80% the mass of the Earth?
Yeah.
Yeah,
And
a
you
lot
do
of
this
mass.
and you do this in Kerbal Space Program too. You can do these.
Yeah. I mean, essentially
Obviously-
every single flyby is a gravity assist, but
Yeah, but it's
This
do
was
you want to do that?
yeah. All right. But, so to Venus, it doesn't really care. The parabolic orbit is exactly the same. However, compared to the orbit around the sun, that momentum exchange causes you to get a heliocentric orbit that dips down to Mercury's orbit,
Yeah.
to where you can intercept it and do a flyby.
So like a big smiley face.
Yes. Right.
Because I
So
think isn't the delta V to get to Mercury's like orbit like 7 kilometers a second
it's
directly?
I think someone I remember reading one of the sources where basically I think it was with the ESA mission. They said that the delta V requirements to get to Mercury are as high as sending it to like one of the outer planets.
Yeah, because it's in the sun's gravity well.
Yeah. Again, it's booking it around at like 30 miles a second.
Yeah.
And then, of course, it's also really small, so you don't have a whole lot of gravity there to work with
Yeah.
once you get there. So, now doing a flyby of Mercury is possible. Right? So, JPL kind of gets excited about this.
Yeah. I'd be excited too.
Next slide, please.
Yay.
So, we now have to introduce our main character. Well, actually, this is the only slide we're going to mention him. So, here is Giuseppe Bepi Colombo. He's a math magician from the Institute of Applied Mechanics in Padua, Italy.
Padua.
Padua, Italy.
It's where one of the Shakespeare's plays takes place, right?
I don't know.
Isn't one of them? I remember they mentioned Padua. I don't,
Padua.
I'll shut
All right,
up.
it's Padua.
I'll shut up.
Right,
He's
Italian.
he's looking at me judgmentally. So yeah,
He's Italian.
that's true.
Yeah.
Oh, so he's talking.
Yeah, this is him talking. Yeah. But JPL is really excited about this new mission, and so Bepi Colombo was invited to participate in a conference on the Earth-Venus-Mercury mission by JPL in 1970. Now, Colombo, he noted that doing a flyby Mercury in 1973 would put the spacecraft on an orbit that is roughly 176 days long.
Which
What is-
means it could hit Mercury again.
Which means you can hit Mercury again in the same orbit that this MVM mission would take. Mercury would orbit the sun twice and return to the exact same position. So a second encounter with Mercury was possible. You're going to get 2 flybys for the price of 1.
Yeah.
Yeah. NASA had already approved the mission by the time of this conference, but they're excited.
They're like, yeah, we did this twice. Woohoo! Mercury.
We got 2 missions for the price of 1. Like, heck yes.
Woohoo! Thank you, Bepi. And he's the namesake of the new probe going there.
Yes.
Spoiler alert.
Spoiler
Sorry.
alert.
I'm sorry. I'll edit that out. I'm not gonna edit that out.
Thank you. Next slide, please.
Hey.
So, Mariner 10, Mars,
Woohoo.
Venus, Mercury, 73.
Woo.
Is this probe? It weighs 533.6 kilograms, or about half a ton. It's powered with a 222 Newton hydrazine motor. It has 6 orthogonal reaction nitrogen jets, basically RCS thrusters.
Yep.
4 of them are around the body. 2 of them are on the far side of the tiltable solar panels.
Oh, so they're like there and
Yeah.
there.
Yes.
Okay.
These will come important later.
Ooh.
Yeah. So the cost had to be under $100 million. They got it at $98 million. I don't remember if that's in modern money or 73 money. I think that was in 73 money, so that's like $5 billion in today's money.
Yeah.
And it was built by Boeing Aerospace.
Yep. They have experience building spacecraft.
Yeah, they do. I mean, you have aerospace engineering companies building aerospace engineering projects.
Yeah, like Chrysler, the aerospace company that built the Saturn 1B first stage.
Yeah.
Yeah. Chrysler,
Go Chrysler.
the car company. Yeah.
Mary Chrysler.
Yeah, there we go.
Yeah. So, Mariner 10 basically has 2 objectives. Right? Its primary objective is to look at Mercury, right? To conduct exploratory investigations of the planet Mercury's environment, atmosphere, surface, and body characteristics during the 1973 Mercury opportunity.
Go there, take pictures.
But in order to get to Mercury, the way that it's going, it's flying by Venus. So its secondary objective is to take pictures of Venus, right? To obtain environmental and atmospheric data from Venus during the flyby of Venus, to perform interplanetary experiments while the spacecraft is en route from Earth to Mercury, and to obtain experience with a dual planet gravity assist mission.
Because if you want to go to, you talk about Mars missions, you're talking about doing gravity assists with Venus for those. So, hey, get some practice on something that doesn't have people on it.
Yeah, exactly.
And if you want to do this in the future,
yeah, exactly.
You gotta start somewhere.
Yeah, but also they were really building up, during this time they were really building up for the Voyager missions.
And when we say Voyager, referring to the big Mars mission, or Voyager as in the interplanetary missions?
Voyagers 1 and 2.
Okay. Because the original Voyager was Mars landers, launched on Saturn V.
Oh.
Yeah.
Interesting.
When the Voyager probes finally die, we'll talk about it.
They have to end first.
Which we might be getting close to one of them this 2025 year.
The year of our Lord 2025.
Yeah.
Which is current year in which you're listening to this.
Yep.
All right, so let's get more familiar with the spacecraft and the instruments on board.
Yeah.
Next slide, please.
Okay. Ooh.
So it has an infrared radiometer, right, or radiometer, however you want to pronounce it. Right. This is used to measure the temperature of the surface of Mercury as well as the cloud tops of Venus.
Cool.
Right. Basically, yeah, it's going to look for temperature variations across different surface features and along the terminator. That being the when a day goes to night.
Yeah, Arnold Schwarzenegger. Yeah.
Yeah.
Yep.
Big robot skeletons from the future.
Yeah, on Mercury.
On Mercury. Mm-hmm.
I mean, it's really hot there. It's metal, right?
It's liquid metal.
There we go.
And hey, they used Mercury for the T-1000.
That's true.
But that's the element, not the planet. All right,
I don't
and
follow.
the reason why this is looking in two different directions, separated by 120 degrees, is basically to say, okay, here's the temperature of the thing we're looking at, and for reference, here's space. Here's the black void of space.
The cold thing.
Here's the cold thing for reference. All right. Next up, we have the plasma analyzer, right? That's used to study the...
That's from Star Trek.
That's from Star Trek, right? It's plasma analyzer, used to study the interaction between the planet and solar winds, see what's going on with them, what does it do with them. Yeah. Basically, so it has two of them. One of them is looking at the sun. One of them is looking away from the sun.
Yeah, that makes sense.
Yeah. Then we have a good old magnetometer.
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 Okay.
Magnetometer. Yeah, obviously magnetometer. Right, it's used to measure the potential magnetic field around Mercury. Because again, no one's ever been there. We don't have any good pictures of it. We don't know what's going on at Mercury.
How many Bronze Age civilizations are there?
Probably a lot, you know?
Yeah.
Because there's plenty of bronze on Mercury, I've been told.
Yeah.
The moon's made of cheese.
As we all know.
Yes.
There's a documentary film about this called Wallace and Gromit.
Mm-hmm. Yes. Yeah, obviously there's two of them, one near the spacecraft, because electromagnetism is one thing, so the electronic components are generating its own magnetic field.
Yeah.
Yada, yada, yada.
You don't want to have that. You got a sunshade on them, too.
Yes, because you're going in real close to the sun, right? Mercury is about 3 times closer to the sun than Earth is, meaning because of the inverse square law, it has about 10 times the brightness and thermal energy from it.
Yeah, so, you might want to put some sunglasses on for that. Yeah, but a sunscreen.
Get some sunscreen, thermal blanket.
Yeah. Ooh.
Get a towel.
Definitely.
Next slide, please.
Next slide, okay.
All right. We also have the high energy particle telescopes, right, used to observe high energy particles from the sun and beyond around Mercury. All right. It can measure atomic nuclei up to oxygen. It's big.
Yeah, but oxygen's pretty heavy, yeah.
Yeah, it's pretty heavy. It's like 8. That's the atomic element number? 8? 8 protons?
That sounds right, yeah.
Yeah.
Carbon is 6.
It's pretty big.
Yeah, it's a big one.
Yeah. Is carbon 6? Bacon? Whatever. So a similar device...
I'm an engineer, not a chemist.
Yeah. Fair. But a similar device is being flown on Pioneer 10 and Pioneer 11 during the flight. Right, so Pioneer 10 and 11, they're on the other side of the solar system, going out.
So they're working in conjunction.
Yes. Yeah. Getting all that high energy particle stuff.
Yeah, kind of count something.
Gotta count that something, yeah. Next up, we have the UV spectrometers, both the occultation and air glow.
Okay.
Basically, the occultation is looking like when it gets when you put the sun, when you have the potential atmosphere of the planet between the sun and the spacecraft. Right, it's basically looking at the UV spectrum and seeing, okay, what drops first.
Yeah,
and that'll tell you the composition.
Yeah, because that's how we actually do exoplanet atmospheres with this now.
Yeah, the
We've been
James
able
Webb
to-
Telescope, right?
Yeah, I think it's James Webb has been able to do that
Yeah,
because it changes because the atmosphere will absorb some of it
yeah.
and scatter.
Yeah, you can see that it's like, oh, that's what it's made of.
Yeah,
Because again, there could be a potential atmosphere around Mercury. We haven't been there.
yeah. There could be Mercurians. They could be doing weird things.
Could be a Bronze Age civilization.
So it's got a lot of smoke. That's what they'll find.
Yeah. And then you have the air glow spectrometer, which is looking for the neutral constituents of hydrogen, helium, carbon, oxygen, argon, and neon, because that's kind of what they assume, that if Mercury did have an atmosphere, this is probably what it would be made of.
Well, of course, you need those neon signs, right? Sin City, you know?
Yeah.
Now it's got some atmosphere.
Yeah, Sin City on Mercury by those Bronze Age civilizations.
Yes.
Bronze Age neon signs. Next slide, please. All right, and then finally we have radio science and TV telescope cameras. Right, with radio science, you're comparing the expected trajectories, the actual trajectories to determine the mass, density, and composition of the planet.
Mm-hmm.
And you're also analyzing the effects that the planet has on the radio waves to determine temperature, pressure of atmosphere, and ionosphere, as well as the radius of the planet, right? Because as a spacecraft goes in front or behind of it, compared to the radio telescope that you have on Earth, right? The receiver on Earth, basically, it's like, okay, it cuts out at that point, it reappears on this point. The spacecraft is so far away because I've measured the response time, and I'm the third point, so I can use basic trigonometry to figure out the distance and the radius.
And we see what the civilization's like for music, too.
Mm-hmm. Yeah, where they got blasted.
Yeah.
And then finally, TV telescope cameras to take pictures.
The important things.
The very important things.
Get some paparazzi going on this flight.
Mm-hmm. Because it's going to go, stop.
Yeah.
All right, next slide, please. So now, Mariner 10 has had some upgrades compared to its previous iterations.
So it's been at the gym, it's been working out.
Mm-hmm. It went to the shop, got some ghost flames painted onto it, put some batteries in there.
Oh, yeah.
Right, so the nitrogen reaction control gas tank was increased from 2.45 kilograms to 3.62 kilograms. So it's a lot bigger. A lot more nitrogen for the RCS. The improved propulsion unit doubled the delta V from 56 meters per second to 122 meters per second, right? This is because, when you're doing gravity assist flybys, you still want to be able to have correction maneuvers.
Yeah. You can still miss.
Yeah, you can still miss, as we will see. The solar panels gain the ability to tilt, right, from 0 to 76 degrees instead of being fixed at just 60 degrees.
Oh, because you're going close to the sun, so you have to be able to,
Yeah, you don't want to melt the thing. It's like, yeah, you're getting a whole lot of electricity from the sun because of photovoltaics, but also you do not want it to be fully exposed because it'll melt it.
I saw sunshine. I don't know what
Exactly.
happened. Yeah.
Yeah.
Yeah, we'll see this also with the solar panels for Messenger.
Yes.
They're built differently.
Yes. Also, grid articulations were added to the antennas for improved communication.
So they can point.
Yeah, they could point. They could point better. Also, solar shields were added to the spacecraft because again, it's gonna be roasting in the sun.
And so you know that you're friendly to the Bronze Age civilization coming in.
Yes.
All right, what paintings are you to put on the sun shields?
Yes. Signs of peace.
Yeah.
Also, a solar door was proposed for the engine, but that was kind of a engineering potential failure point because if the door gets stuck and the engine fires up, it could blast off the door, and now Now it's open and exposed to the sun. Or if it gets stuck open, the engine's exposed to the sun. Then they realized, hey, wait a second, the engine can take the heat.
It's an engine.
Yeah, no door was needed.
Yeah, you don't want to, because if it gets stuck, you'd be pouring hot gases back into the engine bay,
Yeah.
which you probably don't want to do.
No, you want to do that, definitely. That is something that is desirable for the success of your spacecraft.
Hi, I'm Mars Observer.
Yes.
It's a good-looking spacecraft.
Yeah. Most advanced Mariner spacecraft.
Oh, yeah. Some plasma science, infrared. Watch some TV.
Mm-hmm. To protect it from the sun and show the civilization living there that you're there for peace.
Hopefully.
And paparazzi.
Yeah.
Next slide, please.
Hey.
So, here is Mariner 10 being prepared, right? Being built, being loaded up, being tested, all this fun stuff.
It looks like it's a robot looking at me from like an 80s kids movie.
Yes, the two cameras right next to each other look a lot like eyes.
Yeah, you got the mouth kind of here, right?
Mm-hmm.
And it's kind of, T-posing dramatically, too.
It's asserting dominance. Like, 'cause it looks like it's glaring at the people who are working on it.
You're going to send me where?
It's looking so very judgmental. It's like a cat.
Yeah. You got the little heat vents, too.
Yes.
The Venetian blinds.
For your spacecraft. Again, right, for the Bronze Age civilization. Show you're in peace.
Yeah. And to
They'll see
signal
that
people.
from orbit.
Yeah, of course.
Next slide, please.
Good-looking spacecraft, though.
Yeah.
Ooh.
You can see here it's being tested for the sun shield. Make sure that it actually protects the spacecraft and everything is put into the shadow of it.
Yeah, to see where, make sure, again, like in sunshine, one of the antennas gets bad.
Yeah, it gets burnt off, roasted.
And it causes a fire in the oxygen garden.
Yeah. We don't want that to happen.
That'd be bad, yeah. Especially on this, which doesn't even have one.
Yeah.
You want to fry the TV
botanical
camera.
garden. Wait, where did it get a botanical garden? Oh, one of these people, they found it, they put a little potted plant on it, and then it accidentally caught on fire.
Yeah. Good looking spacecraft. This is a good shot, too. Looks cool.
Yeah.
Middle one.
Being glowing and all that.
Yeah. Good looking spacecraft.
Yeah. Next slide, please.
Okay.
Now it's being packed up, loaded up, and put on top of the launch vehicle.
Yeah, big solar arrays, too, so kind of folded up like, it's like doing the A in YMCA.
Mm-hmm. Mm-hmm. Yeah, it fits nicely into the cone.
Yeah, that's how they were designed. Weird.
Yeah, interesting.
Yeah, kooky.
Bizarre.
Neat spacecraft, though.
Yeah. Next slide, please.
Hey, look.
So, launch.
Woo!
All right, so the launch occurred at 12:45 a.m. Eastern Time on November 3rd, 1973. They had a really short window to launch, and they got it.
Good.
So they launched aboard the Atlas Centaur.
This guy.
It was from Launch Complex 36B in Cape Canaveral, Florida. All right, this put the Mariner 10 in a 117-mile or 188-kilometer parking orbit, and then fired up about half an hour later to put on a flyby of Venus. Right, so it's flying basically the opposite way or it's firing up the opposite way of Earth's orbit.
Yeah. Again, you can do this in Kerbal Space Program, too. You'll hopefully discover this by now if you play Kerbal Space Program.
Hopefully. Play Kerbal Space Program.
It's fun. You can do missions like these.
Yeah.
I've actually had to save one of my missions because I was using ion engines to go in orbit of, what's the inner one called?
Moho?
The Mercury. Yeah, Moho. And they didn't have enough time, or they overheated. So I was trying to save the mission I did like 3 or 4 flybys where I kept trying to break into the system. It didn't work. But
oops.
and for you rocket nerds, that's just hanging off the side of the Centaur. That's a hydrogen vent.
Okay.
You can see it on the Atlas too. Like the modern Atlas 5. It's still in use. It's a big hydrogen vent.
Some things never change.
Yeah.
All right, so what?
We're going to slide. We're going to Mercury. Venus first.
Next slide, please.
There
So almost immediately we run into problems.
Oh no.
So the plasma door, remember the plasma analyzer from Star Trek?
Yeah.
Well, one of the doors failed to open, and so no solar wind was detected when they turned it on.
That's not good. And the plasma door sounds like a Star Trek thing.
Yeah, have to access the plasma door.
Yeah.
But fortunately, remember, it's in two pieces, right? You have
Yeah.
the one that's pointing away from the sun, the one that you have is like scanning. Pretty
Yeah.
sure the scanning one was still working, and so they used that one throughout the mission. I know
Okay.
one of them broke. I think it's this one that was still working.
Okay.
Then, wait, next slide, please.
Slide.
Nope.
Nope.
Okay, go back. All right. So, second problem is that the camera heating system did not work, and the thermal insulation. Remember, it's meant for going to Mercury.
Yeah, to keep it from melting.
Yeah. So it started cooling it down like really fast. Now you have
That's
to remember that
good.
electronics still have like operating temperature limits.
Yeah.
Yeah. So this is starting to fall. They're worried that it was going to fall below that, and like, okay, now the cameras don't work.
Well, we'll get some really good, data that's not pictures of Mercury, the planet we've never been to.
Yeah. Fortunately, though, they found out, like, hey, this thing can keep itself warm if we just turn it on.
Oh yeah, that probably helps too.
Yeah, so they turned it on and just left it on. throughout
So
the-
they just changed the thermal patterns, like how you operate, the operational patterns.
Yeah, I imagine. Yeah.
Yeah. Neat.
So, yeah, so they turned it on. It's leaving the Earth-Moon system, so why not get some pictures? Right? So these are some of the first images from Mariner 10. Looking
Nice.
at the moon.
Well, I hope this is the moon.
This is the moon. Yes, this is the moon.
Yeah, Earth got really weird looking.
Yeah, and plus, I mean, they expect Mercury to be very moon-like, so
Yeah.
this kind of helps, set up the expectations of like, okay, this is kind of what we're going to be looking
This is
at.
where, don't get too excited, guys.
Yeah.
This is what you're looking at. Okay.
Yeah, so, we're taking a good look at all of the moon.
Yep. There's the moon.
There's the moon, full of craters. Next slide, please. All right, and so actually, Mariner 10 helped to start mapping out like the North Pole of the moon.
Oh, cool.
Alright. Yeah, to get closer images, to map out kind of like how it looks, and also create mosaics of the disk, as you can see on the right.
Yeah, because that's what we have to do with Mercury.
Yeah, they're gonna be taking a look at it. Yeah. So you can kind of see, like, hey, this is kind of what it's going to be looking like when we get to Mercury.
This actually works. Good.
Yes, yeah, the camera, it works. It's not so cold it can't work, and it's doing really well with the mosaics and the images of, well, the moon.
Yeah.
Next slide, please.
Moon's a nice place.
Yeah, and also took
Ooh.
this image, right, with the Earth and the moon.
That's a nice image.
Yeah,
They're like buddies watching a movie together.
yeah.
Oh,
And
it's
also,
the sun.
what?
And it's the sun instead of a movie.
Yeah, they're watching the sun. They're going blind. And plus, you can really see like the cloud formations.
sorry.
You
Sorry.
can really see with like the cloud formations that it's obviously it's winter. I mean, this is launched in November.
Oh yeah, yeah, clouds and things and
Yeah.
ice. Which way is north on this? Because
Up.
that. You sure?
Pretty sure.
Because that crater I thought was on the southern hemisphere. This crater I thought was the southern hemisphere of the moon.
Did you think that?
I thought it was.
Because remember, this is launched in November.
Okay, I must again. I'm not as familiar with the moon as I'd like to be. I'm sorry.
Okay.
Yeah, that looks nice. Weather.
Yeah. All right. So, next destination. Well, so now we're going to Venus, right?
Yeah. Woohoo.
All right. Well, there are more problems.
Oh no.
Next slide, please.
They forget the batteries for the camera. Forget their wallet. Leave the stove on. What next?
Well, so first, correction is needed, right? Because, they missed, right? So you can see that over here in the diagram, there's the desired flyby point in the middle. No, it's not that one. It's the one next to it. It's the left one. Yeah, you circled the.
Oh,
circle
that's this one.
Yes.
Okay,
That's the
sorry.
one.
I saw. I didn't see as big of a point there. Sorry.
Yeah. So that's the point. The second smaller circle that you've
Yep.
highlighted over.
Yep, that little
That's
guy.
what they're shooting for.
Yep.
Uh, as they were leaving the burn to leave the Earth-Moon system, put them over to the far left.
This guy.
Yep. Which is 55,000 kilometers and 3 hours late.
I have had this happen in Kerbal Space Program.
Yeah, that's quite a big miss. So,
Well, not for me in Kerbal.
yeah. So the spacecraft performed a correction burn on November 13th, so 10 days after launch.
Okay.
That put it on a much better trajectory for the flyby. That was the first one you circled.
So this, post TCM1 orbit. So it's going to hit there. So that's close.
Yeah, not close enough though, because it's still 1,400 kilometers away and 2 minutes early.
So they were hoping to get in within here.
No, they're going to the desired flyby point, and specifically a 400-kilometer wide circle around it.
Okay, that makes sense. All right.
So 1,400 kilometers is still too far away.
So you have to do another maneuver.
Yes. But the problem is that when the gyros are activated, the data system kept resetting to 0 for no known reason.
I've had that happen.
Yeah. Also, the high-gain antenna had connection problems due to the low temperatures and needed to be constantly warmed by the sun.
The mission going to Mercury gets too cold.
Yeah, well, I mean, again, it's designed for extreme temperatures, and right now they're operating at really cold temperatures. It's like Concorde, you know? Supersonic flight Concorde works great at supersonic flight. It sucks at everything else.
Yeah.
It's subsonic flight, right? So, again, Mariner 10 is designed to work very close to the sun, not out at Earth.
Yeah, that could be a problem. I remember one of the earlier Mariner missions. I think it was a Mariner mission. The star tracker got lost. Because it's supposed to look for the star Canopus.
So I'm going to stop you there.
Oh, okay. I'm going to
Because
shut
it's
up.
this one.
Oh, okay. Okay.
All right. We're going to get there. We're going to get there.
We're getting there. Okay, we're getting to Canopus. Okay.
Yeah. Yes. So the problem with the high-gain antenna canceled some planned airglow experiments.
I'm devastated.
Just not great. Fortunately, Mercury doesn't really have much of an atmosphere. Oh, we'll get there.
Oh, spoiler alert. Oh, you're getting mad at me for spoiling everything.
Sorry. All right. But on January 8th, the spacecraft automatically switched over from main power to standby power chain. This was irreversible.
This thing's cursed.
Yeah, it has a lot of problems immediately.
Mercury doesn't want us to see it. There's something there.
There's something as the Bronze Age civilization. They're there. They don't want us to. They don't want visitors, and they'll curse your spacecraft.
Yeah, this is for Tony in 20 years.
Yeah, this is a prequel, right? This is a prequel.
Yeah. Okay.
So now they had to be kind of careful with like transferring power and communication things, because it's like we don't want it to go from solar power to battery power, because that would just doom the mission.
Yeah, because then it's okay. Well, how much time do we have left? 5, 4.
Yes.
Yeah. This is a cursed mission already.
Yeah. But fortunately, they did do the second correction burn that was made on January 21st, 1974, and that put the spacecraft within 17 miles of the desired flyby point.
That's within the 400 radius,
kilometer
right?
wide. Yeah. So basically dead on.
It's for something built in the 70s. That's pretty good.
Yeah, pretty dang good. Yeah.
Flying interplanetary trajectories.
Yes.
With everything broken.
With everything breaking. Speaking of things breaking, the gyros failed. Like, they started oscillating, and this started bleeding too much of the RCS thruster gas, because it's now like trying to compensate for the oscillations. So the team decided to turn off the gyros and let the star tracker guide the Venus flyby.
The thing I brought up.
The thing you just brought up. Yeah, and there was a risk of this, because it seems like the way that the star tracker was programmed is basically just to look for the bright spot. And so if it sees the bright horizon of Venus, it'll get lost.
Yeah, is this the next slide, or is that?
Hang on. What are you gonna say?
Well, the next slide talks about the star tracker. As I bring up what I know.
Not yet.
Oh, not so. Is it okay to bring up how I know Star Trekkers work?
Not yet. Not
Okay.
yet. Not
Okay.
yet. We're not going to talk about that yet.
Okay.
So,
Another thing's got to break first.
well, next slide, please. First, we got to go to Venus.
Oh, okay. So they're just working this problem. Like, oh yeah, we're at Venus now, guys. Uh-oh.
Yeah, well, the Venus encounter takes place February 10th. This is
okay.
late January, right? So we're a few weeks away.
Okay.
But now, we're finally at Venus.
Woohoo!
We got to do the flyby.
So I can see them taking pictures and doing scans.
Yeah, this is a great illustration. Again, from the book I mentioned earlier, The Voyage of Mariner 10. It's a lot of these. They're great.
I do like these kinds of diagrams.
Yeah, beautifully illustrates what's going on. So, next slide, please. So they started taking some photos, and finally, they see the limb of Venus. And now it's like, okay, secondary objective, let's take a look at Venus.
Woohoo! Venus. Yeah.
Next slide, please. So, as you can see, kind of like with Mercury, Earth-based observations were not great of Venus. And the two previous Mariner missions that did a successful flybys didn't have camera systems. So this is the first up-close images of Venus.
Man, look at it.
Look at it.
A lot of clouds.
Yes, it is just caked in clouds. It's a very thick atmosphere.
As we discussed with Vega.
Yeah.
Man, someone's looking at these pictures going, I'd love to put a balloon there.
I want to put a French balloon there on a Russian spacecraft.
Yeah.
I want to see him go along the jet trails.
And then have that probe smack into a pterodactyl or something. What were we joking about?
Does a bird strike on the way down. Next slide, please. So, Venus's clouds. If you notice, they have a very distinct chevron-like shape. Yeah, they're shaped like a V.
Yeah.
Yeah, like that. Based off of these images and their estimates, basically the idea is that you have equatorial heating, the part of the Venus that's the hottest. This causes the air to like warm up, it rises up, and then it goes over to the coal. The coal like poles.
Yeah. Isn't this called super rotation?
Maybe?
I think that's what this is called. Because it's the atmosphere is moving faster than the planets spin.
Yeah, the clouds move around Venus once every 4 days, whereas Venus rotates, once every 270?
Yeah, so it's super rotation. That's how the balloons are able to, because the balloons landed on the dark side, and then drifted to the bright side.
Yeah, because these are just they're booking it. It's like 200 miles per hour winds.
Oh, yeah. We discussed this on Vega. Go back to that episode.
That's a great one.
That was a fun one.
Yeah. But you can see, like, they're creating the diagrams of this based off of the images that they're getting back from Mariner 10. And you really see, like, the bow-like waves, the subsolar region, the polar rings, and the huge, big chevron shapes.
Yeah.
Yeah.
Really
Awesome.
interesting atmosphere.
Yeah. And you could also map it out.
And yeah, so now you know how Venus works. Isn't this where they discovered jet streams?
Maybe. I think, they discovered jet streams on Earth a long time ago, but I don't remember. Next slide, please.
I'm an engineer, not an atmospheric scientist.
Yeah, not a meteorologist. Right? So you can map it out and see, like, the full 4-day rotation across it, and how it preserves that chevron shape.
Yeah.
Because it's being warmed up, heading west at really high speeds, and also heading north. That's what gives it the chevron shape.
Yeah, because it's atmospheric dynamics.
Yeah. But I mean, there are a lot of, like, just great, gorgeous pictures of Venus that Mariner 10 took. Right? Next slide, please. Like, really. You lower the contrast, or you give it, like, more of the natural contrast. You could really see just, like, how incredible.
Because look at those. Like, the streaks there, and you can see the big chevron shape, with those. Isn't there a polar vortex on these?
Probably.
I think Venus Express discovered those.
Yeah. Okay. But hey, if you take these images, you do just a tiny tweak of post-processing, you will get, next slide please,
Ooh.
these beautiful images of Venus.
That's why Venus is so bright in the night sky, too.
Yeah, it's because it's caked in these bright white clouds.
Yeah.
That's why it's so hard to get any detail out also.
Yeah, but look at that, though. It's gorgeous. You can see the streaking, too.
Yeah. It's absolutely incredible. And these are the first up-close images of Venus.
You can't really live there, I don't think.
No.
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 Not good
It's-
real estate.
Yeah, it's a pressure cooker, if you recall from Vega.
Yeah. Yeah, again, the probes that landed lasted an hour.
Yeah.
Really nice looking planet, though.
It's beautiful.
I'd like to see more missions there. It's just not that. It's the problem is missions are expensive, and if you want to go to the surface, it's $100 million for an hour.
Yeah. Yeah.
And from orbit, what are you gonna see? Oh,
Clouds.
Look, clouds.
Yeah.
You can get that at Jupiter. They got moons.
Yeah.
Yeah, Venus is nice.
Yeah. So, but this is not the main purpose of the mission.
No, we gotta break more of Mariner 10.
Yeah, we got to break more Mariner 10,
What broke next?
and we got to go to Mercury.
Yeah, let's go to next
Well,
slide.
actually, remember the Star Tracker we were talking about?
Yeah.
Next slide, please.
Hey, look.
So, the gyros are still acting up, and it was wasting the RCS gas
That's not good.
when roll tests were being done, right? Because it would just keep oscillating,
Yep.
which is not great. So the Canopus Star Tracker was orienting the spacecraft, but was easily disoriented by bright objects.
Yeah, because it's the way star trackers work, at least at this stage, it's, well, you know where one star is in the night sky, and based on when you're launching, like your launch configuration, it'll be, there. So you'll find it, you'll be fine. The problem is they said, look for a magnitude 6. It's a magnitude 6 star. There it is. Well,
Well, there are closer things that are brighter.
yeah, you have debris from like the Centaur or, other parts of the spacecraft breaking off.
Mm-hmm. Yeah, or just like weird, random, bright objects coming from the sun.
Yeah, that's the civilization on Mercury telling us to go away.
Yeah, throwing the spacecraft off. There were 2 instances that threw the spacecraft off, and the gyros were wasting more gas trying to correct it, right? Trying to reorient the spacecraft. Because it was like,
Run out.
yeah, I mean, again, because of we discussed earlier, the Mariner 10 does have upgrades compared to previous Mariners. Doesn't have an infinite supply.
Yeah. There's only so, again, as I've discovered in Kerbal Space Program, you only have so much propellant.
Yeah, you only have so much propellant. It's not like you're going to stop at the gas station to get more. This is a one-way trip.
Yeah. Not good.
Yeah, so basically these random bright objects would just be like, ooh, shiny, and the Star Trek would go, oh, I gotta look at that now.
Oh, that's where I am. Thanks.
Yeah, boss said look at the brightest object, I'm looking for the brightest object.
There you are.
Woo! Woo!
Yeah. Luckily, modern star trackers are like, okay, so here's this constellation. Like, that's how they work now. It's like, okay, these stars in these places, that's how I know where I am.
Yeah, you gotta look for the specific configuration and not just the bright thing.
Yeah.
Yeah. So using the gyros and thus reorienting the spacecraft was kept to a minimum. It's like, okay, we cannot afford to keep wasting gas. All right.
Yeah.
This meant that the third correction maneuver, with the spacecraft's current orientation, would put the spacecraft on the night side of Mercury. But it would allow it to encounter Mercury.
Again.
Well, the first time.
Yeah, but it says allowed it to cover Mercury again.
Yes.
Yeah, because on the dark side, it's like, oh yeah, there's the one problem with some of the early manned Mars mission studies, because they had plans for flybys, but the flybys would take place on the dark side of Mars. You have at 24 hours, you do a flyby on the dark side of Mars. You send humans there.
Yeah.
for a 1.5 year long mission, 1 day at Mars, on the wrong side.
That's the best place to put them.
Yeah, good use of taxpayer dollars.
Yes. So next slide, please. So for the third correction burn, they fired it up on March 16th, 1974. Right, and it changed the velocity of Mariner 10 by 17.8 meters per second, or 122 total budget. So this put the encounter 200 kilometers closer than expected, but this was fine. It's not gonna hit. It's not gonna hit the big thing.
That's within That's a nice range. You can work with that. I
Yeah.
like this diagram.
Yeah, shows that it's 103 degrees between the sun and Earth. You're firing up the rocket, and it changes it by a little bit.
Yeah.
Yeah. So let's go to Mercury.
Ooh.
So it's going to be approaching it on the one side, flying around the night side, and then looking at it from the other side.
Yeah. Because you're there. Take pictures of it.
Mm-hmm. And also going to do the UV spectral analysis, right? Look at the occultation, seeing, does it have an atmosphere?
Yeah. Is this place hopping or is it dead?
Yeah. What all is going on here? Right, so next slide, please.
Ooh.
So finally, with March 29th, 1974, the spacecraft gets closer and closer and closer until... Next slide, please.
Ooh.
It arrives.
It's a good-looking place.
That's a good-looking place. Right? You can see that this is Mercury.
Oh, yeah, it is.
These are the first up-close images of Mercury with any sort of discernible detail.
Yeah, any pictures of Mercury. It's not just the bright thing in the sky.
It's not just that dust speck we were looking at earlier. It's like an actual happening place.
A lot of craters.
Oh, yeah. A lot of craters.
Yeah, I know the names of some of them because I'm starting up on Messenger. So, yeah.
Well, actually,
It's an interesting place.
the first one that was named, if you'll notice, you could see it. It's the bright one.
This one?
Yeah, it's that bright one. Yeah.
What's its
That-
name?
That is Kuiper Crater. Next slide, please. Yeah, the bright one over on the left. Yeah,
That's Kuiper.
that's Kuiper Crater, named after the Kuiper Belt.
Yeah, that guy.
Yeah, that guy. It's because Dr. Kuiper, was on the Mariner 10 team. He was on the television team.
Neat. He's
Yeah.
doing planetary science, right?
Yeah. Unfortunately, though, he had passed away in December of 1973.
Another thing broke.
Like him,
Yeah.
I guess.
This mission's cursed.
Yeah. Well, yeah. But I mean, to honor their dead friend and colleague, they decided to name the first crater after him.
That's nice.
Yeah. So that's Kuiper Crater, first named crater on Mercury. But also, you can see that the Mercury itself is just full of craters.
Yeah. It's another rock full of craters. Great.
Yeah, it's like
So there's no atmosphere.
Yeah, there's essentially no atmosphere. There's nothing there. It's very moon-like, right?
Yeah.
Obviously, you can tell by the enormous amount of craters on there that there's not a whole lot of geological activity going on as well.
Yep.
Crater count is a great way of telling that because it's basically space weathering. So it's like, oh, how recent is the surface? Oh, it's just covered in craters.
Yeah. Oops.
Old. All right, but you can see that it is just like with the moon. The craters come in different sizes, different shapes, different forms, different ages.
Yep. So you got one here. We got a big mountain in the middle.
Mm-hmm.
There's a lot of those.
A lot of those. Yep. You could also see debris rays coming off of them.
Yep. You see that? You can see some kind of cracks too, almost.
Yeah, some fractures.
Yep.
Yeah. You can also see with the image on the right that some of these craters, these really big craters,
Hey.
they're flooded in. They're filled
Yeah.
in with volcanic material. Basically, it fills in and it gets superheated by the impact. It liquefies it, turns it. It basically fills in like a little lake and then cools off and freezes again.
Yeah.
Yeah, and so this happens with a bunch of these, right? You can say that's why
Yeah,
the inside is so smooth.
Yeah. You got all these. Here you can see it.
Yeah. Yeah. Next
That's
slide,
neat.
please. Right. You can also see there are a bunch of these giant like cracks and fractures kind of running along the planet.
Yep. You can see some here. Is this one of the big fractures here? This guy?
Yes, that one I think is like 300 miles long.
Yeah. Is that from an impact?
I don't remember if it's from an impact or, well, another one of the things that discovered on Mercury is basically these giant fractures, these giant cracks. This formed probably because the crater like sank in, or not
Oh.
not the crater, the crust
Oh,
basically
yeah.
collapsed in on itself.
Yeah, the crust is shrinking.
Yeah, it shrank, and so it had a bunch of these materials built up and fractures and cracks and
Yeah, that happens.
all that fun stuff. Yeah.
Yeah, there's a whole bunch of them. Because I remember there's I think it's like tiger stripes on Mercury from one of the impacts.
Yeah.
Like what basin is that? Caloris Basin.
Well, we're gonna get to that.
Oh, hey, yeah. I've been reading about Mercury for for Messenger, so I've been.
Perfect. Thank you. I appreciate you spoiling that. Because next slide, please. But you also see that there are a lot of smooth areas.
That's the civilizations have been walking around, building their towns.
Yeah. They're paving it. They're going to be building up new settlements.
Yeah, do strip malls, everything. Yeah.
Yeah, suburban developments. Yeah.
Just suburbs, nothing else.
Yeah, just suburban sprawl. Nothing else. Yeah, you can see that they're smoother, but it's a lot more ripply than the moon.
Yeah, it looks more.
It's like frozen waves almost.
Yeah, like metal that's cooled down, congealed.
Yeah. Next slide, please. All right, so you can kind of see that from the entryway, the approach place, that you can kind of get a bunch of different features.
Yeah.
You can see these different features. You can see Kuiper Crater again in this image. But also with the diagram over on the right, you can see the ridges, the scarps, the plains materials, and then like the hilly and lineated terrain.
Yeah. Geology.
Yeah, geology. Or hermiology, because it's Mercury.
Yeah.
Yeah.
Hermes. Ugh.
So then it flybys on the night side and goes on to the departure side. Next slide, please.
Hey, that's interesting. That's some lines.
Yeah, huge lines. You also notice that it's a bit smoother on this side.
Yeah, I was trying to disappoint you. So then, get your good side coming in.
Yeah, got the good side coming in and the smoother side coming out. But you may have noticed that they saw something on this side. You can probably see it too, right?
Well, there's a few things, right? You got this.
Mm-hmm.
You got that. You got some lines there. You got some cluster of craters there. There's like some really shapes there.
Mm-hmm.
Looks like it's a duck.
It's a duck. That's a duck.
That's a duck. It's
It's
a
a
lot
cute
of there's a lot of features to look at.
A lot of features. But they found something big. Next slide, please. You see it?
It's the Caloris Basin.
It's the Caloris Basin.
It's this guy.
Yes. Next slide, please. Yeah, so the Caloris Basin is huge. It's 800 miles wide, or about 1,300 kilometers wide, and it's a multi-ringed basin surrounded by a mountain ring, right?
Yeah.
The basin itself is filled with, like, partially melted regolith, so it didn't, like, fully melt. It's kind of remained like a soup, which is why it's still ringed and rippled,
Yeah.
right, because of the enormous impact. But it's very much like a mare-like feature.
Yeah,
Well,
it's like
similar to Oriental Mare on the moon, which is pictured here over on the right.
this guy.
Yes.
Yeah, I think I was pointing that out on our way leaving Earth. That's what I was pointing out. It's this one.
Oh, okay. Yeah.
Because it looks like an eye.
Yeah. I mean, well, it's multi-ringed. Yeah.
Yeah. Can you imagine if that was the side facing the Earth?
Yeah, that'd be creepy.
Yeah.
So we get a face, full
Yeah,
face,
I think religion would be a lot different if we could see, an eye looking at us the whole time.
the eye of the moon glares down at us. But the largest mare on the moon is Ibrium Mare, which is only 700 miles across, or 1,100
Pathetic.
kilometers. Yeah.
Pathetic.
But also, unlike Oriental Mare, you can actually see Ibrium Mare from Earth with
That's
the naked
true.
eye.
Yeah, this is different. Yeah, it's almost indistinguishable from the rest of the features of.
Mercury?
Yeah, that yeah, you know, yeah, you can't see.
The,
Yeah,
the place. Yeah.
the place, the thing where things happened. Yeah,
Yeah. Next slide, please. Ibrium Mare is the big one at the top.
this guy.
Yeah. Again, you can see
Is that
from
yours?
Earth. Yes, this is an image that I took. I took
Doxed.
this picture.
We can find out where you live now.
No, you can't.
Well, I know where you live.
Yeah, you do. No one else does. I'm gonna keep it that way.
That's a big basin,
Yeah, it's huge.
but not big enough, I guess, compared to the real one on Mercury.
Yeah. Remember, Mercury is 1.5 times wider.
Oh, okay, so it's actually not that big.
Well, you saw it.
Yeah, it's pretty big.
I just showed it to you. It's huge.
Yeah,
It's 800 miles wide. It's the size of Texas.
yeah, that's pretty big.
Yeah.
I've driven across Texas. That's pretty big.
Yeah,
It took me a day.
exactly. So, next slide, please. These are closer up images of the basin, the Caloris Basin. I think
can
Caloris means heat.
Yeah, calorie.
In Greek. Yeah, calorie. Yeah.
Yeah, because during chemistry it was calorum. That was the idea of like the particles of heat being exchanged until we discovered, you rub your hands together. Well, where do you get the calorum from, right?
Yeah.
Friction, but yeah,
Yeah. Then we discovered thermodynamics.
yeah. A fitting name for this big basin, though.
Yeah.
Because that looks like just ripples of frozen metal.
That's what it is. It's ripples of frozen metal and rock.
Yeah, because isn't Mercury's surface like iron?
It kind of. We'll get to that in a little bit. But I mean, also, yeah, we'll get to that.
Okay.
We'll get to a little bit of that. Yeah, you can see that like these are around the Caloris Basin. You can see that it's mostly frozen and smooth.
Yeah.
And you can see the ripples and waves, and not a whole lot of craters compared to the other side.
Yeah, probably because the big impact got rid of all of them.
Yeah, that happened.
Yeah.
Next slide, please. So you can see that.
Yeah.
The reason why this side's so much smoother.
Yeah, there's just enormous basin.
Yeah, it's smoothed out everywhere around it.
Bit of a jerk, just kind of stealing the show there.
Yeah, it's kind of the big defining feature of Mercury.
Yeah, that's a reasonable assessment.
Yeah, or at least from what we can see.
Yeah.
Because remember, it's
It's flying by.
flying by.
We'll get better pictures in 2010.
Yeah, we get there. All right, next slide, please. So, scientific discoveries around Mercury. Mercury's mass was measured with great precision. Right, you can see this little diagram. It is 6,223,600 times less massive than the Sun.
Okay.
Yeah, or about a 20th the mass of the Earth.
That sounds about right.
Yeah, because it's 4.5 times the mass of the Moon, and the Moon is an 80th the mass of the Earth.
Yeah, because
So-
Mercury has the same surface gravity as Mars, despite being smaller.
Yeah, that's because 80% of the planet is the thick iron core.
Yeah.
There's another thing that was discovered on this mission, though I didn't write it down. But also, Mercury is found to be more perfectly spherical than Earth, probably
Oh.
because it's not rotating all that fast.
Oh, yeah, that's true. Yeah, because Earth is wider by 7 miles.
Yeah, and that's because it's rotating once every day as opposed to once every 6 months.
Yeah. Has an impact on things.
Yeah. Also, a magnetosphere was discovered around Mercury, though it was significantly weaker than Earth's.
Wow.
It's kind of a debate now of like, okay, but why? How? What?
That's a good question.
Because it's not geologically active, so why does it have a magnetosphere?
It's the Bronze Age civilization on the surface. Just messing with us.
They're doing stuff in the core, in the basement.
Yeah, they saw the core and like, yeah, we could do that. It's really easy to do. Yeah. Why are you guys freaking out so much?
Yeah.
Look, everyone's house can go to the heat, you know?
Yeah, what the heck? They also discovered that the nighttime lows were measured at 90 Kelvin. For reference, 0 Kelvin is absolute zero. Space is like 3 Kelvin, and room temperature is around 300 Kelvin.
Yeah, liquid oxygen is at about 70 Kelvin.
Yeah. So at nighttime, the dark side of Mercury, very cold.
Yeah, very.
Daytime highs reached 650 Kelvin, which is, I think, is about 700 degrees Fahrenheit.
So it's a bit of a temperature gradient. It's like Minnesota.
Yes. Yeah. Everyone talks about Minnesota winters. Nobody talks about Minnesota summers.
Yeah.
When it's 90 and humid.
Oh God.
But yeah, so that's a huge temperature difference.
Oh, it is. Well, yeah.
Yeah.
Again, if it was tide locked, it'd be permanent temperature difference.
Yeah, but it's not tide locked.
Nope,
It rotates very slowly. Once every 2 months.
Yeah, in science fiction stories, they put a city on the Terminator line that's on rails. And so
Oh.
as the rails expand, they push the city forward from the heat.
Oh, that's smart.
Yeah.
I don't know why you'd let the heat do that. I would just, have the system do that. Just build a big train,
And that's why you're not a science fiction writer.
I guess.
Yeah,
Too practical.
I guess so.
They also found that mare-like features are similar to those found on Mars and the Moon. And the amount of craters in them is also similar to like the number on Mercury, meaning that there was a relatively even distribution of meteorites throughout the entire solar system.
Okay, that's good. It's good to know.
Yeah, it's interesting.
Yeah.
Yeah.
Or
Next slide,
is
please.
it?
Another thing too was with the color enhancements. You can show some of the different compositions. This one's
Yeah.
obviously done by M. Robinson from the USGS. So you can see that K, that's the Kuiper crater.
This
It's
guy.
very big, very bright. Shows recently excavated material. It's fresh stuff. The dark and blue is enhanced titanium content. Dark areas and the blue areas.
Ooh.
This is titanium.
Nice.
The bright red material, maybe primitive crust material, labeled B. And then F is interpreted as lava flows.
Cool.
Yeah. So that's mostly what I got for composition. So here's a map that we got from it.
Ah.
First area. Unfortunately, it's not going to get a whole lot better.
Yeah.
Because if you remember, Mariner 10 is going to encounter Mercury once every 176 days. Mercury goes from noon to noon every 176 days. So it's going to only ever see the exact same side of Mercury.
That's why I have a book, like an astronomy book about the solar system, the planets from like 2003, and Mercury is that. Right? It's
Yeah.
the stripe. It's still missing that stripe.
Yeah, because it's...
We just didn't know.
Yeah.
We didn't know until like 2010.
Yeah, this is, again, the only mission to Mercury in the 20th century.
Because it's hard to get to.
It's really hard to get to. Yeah. So at this point we've got like what, 40% of the
Yeah.
planet mapped out?
Yeah, that's good. That's pretty
Yeah,
good.
it's not going to get much better.
Yeah, well. And whose fault is that?
I blame Bepi Colombo.
It's his fault, okay.
Mm-hmm.
We'll blame him, yeah.
Yeah, we'll blame him. Next slide, please. Okay, so we got more problems.
Oh,
right?
goodness.
So the tape recorder switched on and off several times before completely failing.
Oh, jeez. It's just, okay.
Don't use tape recorders.
My goodness. They always break.
Yeah, tape recorders are notoriously unreliable. Don't use them. Fortunately, we don't use them anymore because we've advanced as a civilization. with our technology and recording systems, so we don't need to do that. But
I do
seriously,
like-
don't use tape recorders.
I do like how Mariner 10 looks like it's like flexing, like, ooh, yeah.
Yeah. Ooh. Yeah. You can clearly see the camera on the bottom
Yep.
and everything. Yeah.
Got the magnetometer sticking out.
Mm-hmm.
There's all the parts just falling off, I guess.
Yeah, the paint's chipping.
Yeah, all the tape, the tape's coming out.
Yeah. The tape is flying out. Also, the oscillation problem with the gyros meant that maneuvering had to be kept to an absolute minimum.
Yeah.
So the fourth correction burn was broken up into two. All right, because we're going back to Mercury.
Yeah, we got to make sure you're going back.
Right, we did the first encounter. Got a lot of good science, a lot of great images, but we got to go back. All right, so we're doing a fourth burn. Let's broke it up into two. So the first one occurred on May 9th with a 50 meter per second velocity change. Remember,
That's a big one.
122 total, right? So this is about almost half.
And they've already done about 20.
Yeah, they've already done a few. The second occurred on May 10th with a 27.6 meter per second velocity change, right? So over half of the fuel is being used, or over half of the delta V capability of the spacecraft is being used on this one burn.
Yeah.
Now, these burns put the spacecraft 29,000 miles or 46,000 kilometers above the day side of Mercury.
And this is good, right?
This is good, yes.
Because you want to
Remember, the first one, they wanted to do the day side, but because of the angle changes, because the things were breaking, they had to go on the night side. We want to see the day side because that's like the only side of Mercury we can actually see.
The important side, the one we can take pictures of.
Yes. So next slide, please.
Please go. Wasn't it? Okay.
Okay. So now, because the spacecraft is in a heliocentric orbit, it's orbiting the sun, it's going around the sun, coming back to Mercury at the exact same spot. There comes a point, June 6, 1974, in which Mariner 10 achieves solar conjunction. Right? So Mariner 10 and the Earth is at the bottom, Mariner 10's at the top. Right? Yep. So you can see the sun is directly in between them.
That you don't really want that. It's hard to talk to Earth that way.
Well, actually, this is a great opportunity, because if you remember, mass has the inherent property of curving space-time.
You can test general relativity.
You can test general relativity. That's exactly what they do, right? Radio science was conducted verifying general relativity.
They do that in all these missions now, too.
Yeah, well, you have a great opportunity to do that.
Yeah.
Yeah, it's like, hey, it curves around space-time, right? Basically, the radio signal uses the sun as a roundabout. Right?
And Mercury was used to validate general relativity back in 1915.
Yeah, because the precession of Mercury's perihelion. If you go off of Newtonian physics, it's like you adjust for like 8.5 centimeters per year, per century,
something like that.
But that's less than the observed amount. But when you use general relativity, it accounts for it.
Yeah, because that's how we found like Uranus and Neptune was. Well, Saturn's not in the right spot, so something's tugging on it. That's how we. Yeah. So that's when we found Uranus, but that wasn't moving right. So that's when we found Neptune.
Yeah.
There were like ideas that there was a planet inside Mercury called Vulcan.
Mm-hmm.
We didn't find it because you think you would have noticed it by now.
Yeah. Venus does transits of the sun twice every 100 years. Last one was on 2008 and 2012, right?
I remember that, yeah, because we were driving home when it happened.
Yeah, you said you could see it. I looked up, and I was just blinded by the sun. I was like, how?
Yeah, I could see it.
But yeah, I mean, that's when, Venus is casting a shadow on Earth, which is interesting. Mercury does that a lot more often, though.
Yeah, because it's going...
Yeah, it's a lot closer, right? And even with the angle of the orbit, it still does it a lot more.
Yeah.
So I have pictures of the one that happened in November of 2019.
Cool.
I'm gonna do it again. I'm gonna see when that is and try and do it again. But yeah, so it's out in space, testing general relativity. Next slide, please. Yes. Okay. So a fifth maneuver burn was made on July 2nd with a velocity change of only 3.3 meters per second. Right. This put the spacecraft 31,000 miles or 50,000 kilometers above the day daylight side, right? So it moved it out even further.
Oh, okay.
This increased altitude, which allowed for greater scientific data return, right? Because now you're not being blocked by Mercury because you're being so close to it.
Right.
Now you're constantly, remember, you're transmitting all the data,
Oh, right.
all the images.
Oh, right, because your tape recorder doesn't work anymore.
Yeah, yeah. This is using fancy television technology that can
That's true.
that turns images into radio signals. It also gave better maneuvering options for a potential third encounter.
Ooh.
But we'll see if the spacecraft actually survives to that point.
Yeah, something else will fall off.
Yeah, maybe it'll go from solar to battery power. We won't want that happening. Anyway, so second encounter. Now, because if you remember from the previous slide, actually, could you go back to it real quick? So you'll notice it's going away from it, but also below it, right? 40 degrees below the equator.
So you can see more.
So you can see the South Pole and the daylight side.
Yeah, maybe there's penguins on Mercury.
Maybe there are Bronze Age penguins.
Yeah.
That'd be different.
Yeah.
Yeah. Okay, next slide. Right, so you can see that it's coming out on the approach side on the right, getting good images of it on the bottom, and then swinging out underneath it on the left.
Yep.
Yeah. All right. Next slide, please.
Ooh.
So now we can see a lot of the same things that we saw with Mariner 1 encounter, but with a Mariner 2 encounter. We can see that there are still a lot of craters and these giant scarps going through it, right? These huge things. Those are ray lines recently kicked up,
from an
injected
impact
stuff. You can see there's that.
Yeah.
There's giant scarp.
Little string of craters here.
Yeah, a bunch of those. You see the ripply material on Mercury.
Yeah.
The rough terrain and the endless amount of craters.
If you love craters, go to Mercury.
Yeah. But also you see on the right, kind of near the bottom right, there's like this really big old crater. Not
This
that
guy.
one. No, one next to it.
This guy.
The other next to it. The
This
left.
guy with another one in it?
Yeah, it has a much fresher one inside of it.
Neat.
Yeah. Pretty neat. Yeah, pretty cool stuff.
Yeah. Craters are cool.
Yeah, you can see there's just a lot of craters.
Yeah.
Next slide, please. You can also see that there's just more and more and more craters.
Yeah, a crater with a crater with a crater.
Yeah.
There's one next to it, too, for fun.
For fun, yeah.
You got a couple over here, too. Look at this. Craters on craters.
You got craters on top of craters, right? It's very rough, very cratered, heavily cratered terrain. And over on the right, you can see.
You see crack here.
Oh yeah. There are a lot of these cracks. Over on the right, this is the antipode to the Caloris Basin.
So the other side.
Yeah, the other side. Basically, when the thing that created the Caloris Basin smacked into Mercury, the basically had shockwaves going through the planet, and it rippled and messed up the terrain on the other side. Right, so this is part of that messed up terrain where there's a lot of cracks and squiggles.
Yeah, that's a pretty big hit.
Yeah, I mean it made the Caloris Basin.
Yeah, and it made ripples on the other side of the planet.
Yes, it kicks up debris like that.
Yeah, that's neat.
Yeah, and you see a bunch of these like multi-ring craters, like craters inside of craters, and like that.
There we go. Got another here. Got a little side piece crater.
Mm-hmm.
Ooh, there's one with like 3.
Yeah.
Man, if you love craters, you would love this mission.
Yeah. Again, it's very moon-like, but like the boring parts of the moon.
Yeah, the parts of the moon that everyone knows. Oh, look, craters. Wow.
Well, it's gray and full of craters. Who knew?
Wow. It's exciting.
Yeah. Next slide, please.
Ooh.
But now we can kind of get more of a map. All right, we can kind of like see a lot of the details of like what all is going on with Mercury. And again, it's just craters.
Wow. Man, wow, look more craters.
More craters. You have like the bright fresh ones over on the left.
Yeah, you see those guys. Got a big one here.
Yeah, you got some lower, older ones over on the right near the Terminator.
Yep, there we go. Yeah.
Yep, all those. Messy terrain in between.
That's a really old one. You see it's almost missing.
Yeah.
A lot of craters.
Bunch of craters. A lot of craters.
See if they spelled something, that'd be scary.
That would be pretty scary. Next slide, please. And so you can see that this is like the South Pole, or as close as you can get to the South Pole, because of, the fact that you can only see half the planet.
Yeah, orbital mechanics.
Yeah. But you can still see that there are still multi-ring craters.
Yep,
you can see that there's a bunch of these ripples going along the South Pole, smoothing out the terrain. Yeah.
Those are neat.
You can see a lot of these rays as well coming off of fresher craters. There's kind of a fracture near that big one lower, kind of near around there.
Yeah, you can see this big guy.
Yeah.
You have the big crack there, too.
Yeah. A lot of these.
That's neat.
Yeah.
Nice big mountain range here.
Mm-hmm.
It's a lot of ripples.
A lot of ripples. Next slide, please. And over on the other side, you can see from this huge image that there's just a lot more craters. You can see a lot of these rays going up from the south. Yeah, just huge.
It looks like these rays connect to these rays from this guy.
Yeah.
Look, there's a dead crater.
Yeah, there's a dead crater there. Some fresher craters.
And a nice one here.
Yeah. And some more, I think a few more ripples, especially near the south.
Oh, yeah, like this here.
Yeah. Yeah.
Ripples there, yeah.
Just an endless supply of craters.
I love ripples and craters. This is amazing.
This is great. Next slide, please. Right, so now you can kind of get a really good appreciation for the way that Mercury looks, right?
Big and cratery.
Big and cratery. A lot of big craters, a lot of big rays, these huge lines you can kind of see up near the equator.
Oh, yeah.
Yeah. Yeah, and then just rays from the impacts, and just an endless supply of craters, and then smoother rippled material, surface material. Yeah.
That's nice.
Yeah. So now you can see that got a little bit more coverage of Mercury.
Yeah.
Right? Now we're up to like 45%
Woohoo!
of the coverage, right? So with these two passes, right, the two passes that Mariner 10 has done, right, you get we've mapped out like almost half.
Yeah.
There's still that one slice of the North Pole, but yeah.
Who needs that?
Who needs that? But Mariner 10's still alive.
Yeah, it's still alive. Well, barely.
Barely. I mean, yeah.
I'm fine, guys. Don't worry.
Don't worry about me.
Parts are falling off. It's limping toward. I'm fine. Don't worry.
Yeah. Well, next slide, please. Mariner 10 was put back into a cruise and basically used the antenna and solar panels to orient the spacecraft.
Yeah, radiation pressure. That's what one of the earlier Mariners did.
Yeah,
paddles.
exactly. That's technically the third way to accelerate your spacecraft is.
Yes, but that way sucks.
Yeah, that way sucks. Solar wind sucks. So pressure from solar radiation pushed on the deployed components of the craft, which were adjusted to prevent the use of gyros, because bad things happen when you turn those on.
Yeah.
Yeah. But then the star tracker becomes distracted by a bright object and loses the stars completely.
Ooh, shiny. Ah!
Yeah. This is bad because now the gyros have depleted the gas below the required levels for a third Mercury encounter.
Oh, man.
Trying to reorient the spacecraft.
Oh. So he gets lost, turns on the gyros, and outgasses, runs out of gas. This is like a bad comedy.
Yeah. Well, it hasn't completely depleted all of the gas. It's done it below the required levels for a third Mercury encounter. Well, at least for fully stabilized third encounter.
A useful one.
Yeah. So they decided to leave the spacecraft on a slow, permanent roll, which made exact roll position hard to determine, but I think they used basically the volume of radio signals to...
Yeah, you can do that.
Yeah, to basically figure out, it's like, okay, that's where the antenna is at This is what's happening.
Yeah, because gyroscopes are what get your roll rate.
Yes. But unfortunately, though, Mariner 10 eventually rolled into a null position that broke communication completely.
Of course. Why not?
Yeah. So the team had to go to Madrid to then get in contact with a German radio to then get in contact with Mariner 10.
Because I think that's where one of the antenna farms is, at least for the Deep Space Network is now. It's near
Yeah.
Madrid in Spain.
Yeah, makes sense. But finally, they reestablished communication with Mariner 10 and got it on the correct path with correct orientation. And now everything is good to go for a third encounter.
So we got this one.
Mm-hmm.
We just did this one. 1975?
1975.
So a year after the first one.
Yes. Almost
Cool.
a full year. Remember, it's a 176-day orbit.
Yes,
Right.
it's pretty close.
Pretty close to half a year.
Next slide.
Okay. Next slide.
Hey, look at that.
Yeah. So for the third Mercury encounter, it's kind of going on a similar trajectory to the first Mercury encounter.
Oh, so it's going on the dark side.
Yep, it's going on the dark side, swinging around the back. But it's going to be higher up in elevation, as you can see from the diagram.
Okay.
It's also going to be further away.
Oh yeah, because the tape recorder's broken.
Yeah. Yeah. It's going to be outside the block. It could talk to Earth, right? You see with the Earth arrow pointing up, you see the shadow on the other side. It's outside of that shadow.
Yeah.
Yeah. So, finally, we now have the third encounter.
Next slide.
Next slide, please.
Ooh.
Now, unfortunately, because of the lowered amount of communication that it has, it can really only transmit like the center quarter of the images. But I mean, like,
It's not.
Yes.
Like, you're still getting pictures.
yeah, but also like, guess what pictures you're getting? Craters.
Ah, yeah. Well, look, there's cracks and crevices, and this looks like the moon,
Yeah, I mean, this looks like Mercury.
which
It's
also
far
looks
more
like the moon.
ripply.
That's true. Yeah, I get more of these.
Yeah. Also, the moon has very large definable mares. Mercury has the Caloris Basin.
Which is not a large definable mare.
Correct. It's also, I mean, you saw it.
Yeah.
It kind of looks like the rest of it.
Yeah. Wow. Mercury. Wow, that's exciting. Craters.
The moon at least has, high contrast mares.
Yeah. Well,
Yeah.
you win some, you lose some.
Yeah. But it also reconfirmed a few things on its third encounter.
Like? Oh, we'll go to the next slide.
Next slide, please. Like the magnetosphere.
Cool.
Right? So you can clearly see the solar wind coming in. You have that bow shock. You have the magnetopause.
Yep.
All right? And you have that clearly defined magnetic field, which can be mapped out more with the third Mercury encounter.
Yeah, because you're going in different spots.
Mm-hmm. Exactly. So it's very clear that, yes, Mercury does, in fact, have a magnetic field produced by the Bronze Age civilization trying to throw off everything.
Yeah, trying to mess with us.
Mm-hmm.
So I fried the TV camera, fried the gyros.
It's doing everything it can to prevent this mission from succeeding. But now we've done 3 flybys with this thing.
Yeah. Only 2 were really planned.
Yeah. Yeah.
I mean, barely doing a third one.
Still, we got images, did scientific data, found a lot of stuff with this.
Saw some craters.
Saw a bunch of craters. Huge Caloris Basin. Mapped out like 45% of the surface of Mercury.
Yep.
Pretty good.
Yeah. And
Next
since,
slide, please.
since no one's ever been there,
Yeah,
it's pretty
first
good.
mission.
Even
We
even the Soviets didn't try this.
Yeah.
They probably have the computers to do it.
Yeah. Next slide, please.
No, wait. The Soviets would have the computer that could do this better than us, but they couldn't build the actual spacecraft. That sounds more Soviet to me.
Yeah.
Hey.
Unfortunately, it didn't really last too long after that. So remember, it does the third encounter on March 16th. It's like
Yep. Oh,
8 days later, about a week later, there was an unprogrammed pitch turn that was activated. This turn depleted the remainder of the reaction control gas. So all the nitrogen for the RCS thrusters got burned up.
Yeah. Okay, well, we're done. Bye.
Ran out of gas, right? So yeah, then command signal was sent to the spacecraft that shut off all the transmitters, and the mission was over.
It's like, yeah, fine, turn off. That's it. You're done. Go away. Go
Yeah.
away. Goodbye.
You're done. That's it.
Good day. Good day to you, sir.
Exactly. So that brings us to the end of the mission.
Yeah. It just died.
It ran out of gas because of the oscillation, because of the gyros
Which were broken by Bronze Age civilizations on Mercury.
that were trying to prevent the spacecraft from succeeding.
Yep.
But hey, we got 3 encounters out of this thing.
Yeah, we got to actually see Mercury.
Yeah, up close, in person, measure its magnetosphere.
Yeah.
Yeah,
And found so many craters.
yeah. We also see that the U.S. Postal Service provided this Mariner 10 Venus Mercury nice 10-cent stamp. The
Yeah.
memorial stamp.
That's what I was using on the STS-61B.
Yeah, the commemorative stamp.
Yeah, commemorate this. Don't try to use it on your postage though; it'll fall off or break.
Yeah, it'll break. Next slide, please. So yeah, here it is in full color.
That's
So you can
nice.
see, this is a very successful mission, though.
Oh, incredibly.
Yeah, these are the first that are listed straight off of NASA's website about this mission. It's the first spacecraft sent to study Mercury. It's the first spacecraft to use the gravity of one planet to reach another. It's the first mission to explore 2 planets in a single mission. It's the first spacecraft to use gravity assist to change its flight path, right? It's the first spacecraft to return to its target encounter after an initial encounter. Didn't do it once, did it twice.
Yeah, came back twice.
Yeah, and it was the first probe to use solar wind as a major means of orienting the spacecraft during flight. Right?
This
And
is wildly
as we
successful.
discussed, it's the first spacecraft to get up close images of both Venus and Mercury.
Yeah.
This
Tough
was
little guy.
massively successful.
And as everything was falling off too.
Yeah, despite everything falling off.
Yeah, it's a cute little guy too.
Yeah, see, it's not that big.
Yeah. Cheap and cheery missions.
Yeah, that was the goal of the Mariner program.
And it worked.
And it worked.
We got the entire inner solar system with these things.
Yeah. Yeah. Discovered the enormous, giant state-sized volcanoes and mountains on Mars.
Mm-hmm.
Saw the chevron formations of the clouds of Venus. Documented all of the frickin' craters on the one half of Mercury that we could see.
Well, I think they got the size of one of them wrong. That was one of the first things I was reading for Messenger.
Oh.
Yeah.
Oops.
Well, it was broken, so it's okay. We'll forgive it. The gyros did it.
Yeah, they're doing this with caveman 70s technology.
Yeah.
Yeah.
Tough
Yeah,
little guy.
massively successful mission for Mariner 10. And it would be the last spacecraft to visit Mercury in the 20th century.
The only.
Yeah, the first and last, the only.
Next slide.
Nothing else really like it. Next slide, please. We have to wait until the new millennium to return to Mercury.
And I'm doing that one. There's a lot more pictures on that one.
Yeah. Well, they finally got pixel production up for the digital age.
And I think they figured out how to make gyroscopes.
Yeah, you just got to burn through tons of nitrogen gas.
Yeah. Yep, and I'm doing Messenger after STS-83. So that'll be
Yeah.
fun.
Yeah. So hey, what are we talking about next?
Oh, that's a good... Hey, will you look at that? We're doing STS-83.
Doing STS-83 next.
We're going in combustion experiments.
Yay!
A lot
No
of
crystal growth experiments?
Oh, no, there's some. You saw the
Oh.
list. You saw the list.
Yeah, I definitely looked at that list.
I have the next 2 shuttle missions in that list.
Okay.
So many experiments. Oh, so
I gotta look at that list for a second time because I definitely looked at it the first.
totally, yeah.
Yep.
Your gyroscope was broken, so you didn't really see it all that clear.
Yeah, the star tracker got messed up.
You saw something shiny, and it's like, oh, what's this?
It's like, ooh, whoa, whoa.
You vented all of your nitrogen and got lost.
Yeah, I was huffing that galaxy gas. I got lost.
There we go. The Bronze Age civilization doesn't want you to know about combustion experiments on the shuttle.
They're huffing all of the galaxy gas on Mercury, and it's like you can't have any of it. We'll mess you up with your stuff.
Yeah. Mariner 10, though. Good little mission.
Yeah, great
Well,
mission.
I won't say little. It's a big mission. It's a big one.
It's a huge mission. Again, we visited both Venus and Mercury. First spacecraft to ever do that.
Yeah. Got pictures of it. Broke a lot.
Mm-hmm.
Gravity assists. Gravity assists are pretty fun to do in Kerbal.
Yeah.
I do them a lot.
It's fun watching other people do gravity assist, and it's like, yeah, this mission takes like 85 years, and fortunately, Kerbals are immortal.
Yeah. I have that sometimes where it's like, oh, I'm going to encounter Kerbin again in 300 years.
Yeah.
Oh, wow. Can't wait for that
this
one.
I mean, with this one, with Mariner 10, you had the Venus encounter on February 10th, and then the Mercury encounter on March 29th. So it was only like 5 weeks.
Yeah. Not that bad.
Pretty fast.
Yeah. All right, we got some pictures from Venus. Oh, we're at Mercury now. Holy cow.
Yeah. Oh, where'd that happen?
Oh, where'd that? What was that?
Was that Mercury? Oh, dang it.
Next time.
Next time, yeah. We'll swing around again.
Yeah. And Bepi Colombo, good with orbital mechanics.
Yeah. And that's what the current ESA mission to Mercury is called, Bepi Colombo.
Yeah, and something broke on it.
As is tradition.
Yeah, the ion thrusters on Bepi Colombo can only go up to 90% thrust. Mm-hmm. So they had to add another year to the mission before it enters Mercury orbit. As is tradition.
As is tradition.
But it's got 2 spacecraft on it, though. It's 2.
Ooh,
one's
two
gonna
space.
Yeah, one of them's gonna map the magnetic field. The other one's gonna take pictures of the Caloris Basin.
And that's it.
Oh, other stuff too. Actually, it was gonna have a lander on it too.
Oh, that would have been awesome.
Yeah, they can afford it.
Oh,
And the cute little guy too.
yeah.
Yeah, it would have worked, but no budget for it. But cute little guy.
Yeah, space is expensive.
I know the Russians have been trying to go to Mercury, but I don't think they can. No. Considering their last interplanetary mission was Luna 25, which slammed into the moon. No.
Hey, you could slam into Mercury.
That's true. You can do that.
First spacecraft to slam into Mercury. That would be cool.
Yeah. Oh, actually, that was Messenger. Spoiler
Spoiler
alert.
alert.
Spoiler alert. Second one.
Losers. You're getting second.
Yeah. Mariner 10. Good mission, though.
Very good mission.
The Mariners are pretty fun missions, too.
Yeah, when they work.
Oh, this one exploded.
The first one blew up. Second one worked. Third one blew up. The fourth one worked.
Whoops. Oh,
Yeah.
wait. Who ends this, then?
Well, you, because... Yeah.
Okay, everybody. This has been end of mission. Keep your tape recorders close.
And your Bronze Age civilization's closer.
That too, yeah.
All right, everybody. Thanks for watching. This has been End of Mission.